recommend downloading the Ultimate GRE Quant Cheat Sheet for this. It is a very thorough chapter on exponent rules and sequence properties, both arithmetic and geometric sequences actually, and you're going to need to know that. This is a tough question, and without knowing the formulas and the rules, students are going to struggle to answer this in a reasonable time. If you want to get a top grade on the GRE, you need to be able to whip out these formulas, rules, patterns, tricks, techniques that can save you time, especially because the GRE throws predictable questions at you, predictable time-saving opportunities. And once you spot it, you want to know exactly what to do, take full advantage, and move on. That is how you're going to get a top grade. And the other test prep providers just don't go into enough detail on the formulas and the rules and the patterns that you need to know. They say that you need to understand how everything works, and that is absolutely true. And they shy away from leaning too heavily into the formulas and the rules and so on. But actually, to get a top grade, you really, really, really do need to know them. And you need to know how they work, and you need to practice them a lot, and you need to know how they behave and how they're actually going to save you time. So you can't be a robot, but you need to know them. So go to Ultimate Tuition, download the cheat sheet if you want to get a top grade. All right, so we took this question from my prep club, GRE forum, okay? And I'm just going to quickly look at what it's saying. So it's saying that you have A, B, C, D, okay? You're told that these are 4 consecutive integers, so that means immediately you have an arithmetic sequence. And you know, because it's consecutive integers, right, that the common difference is +1. The common difference is +1. Now, I'm just going to digress quickly. There are many different formulas that you can use throughout your GRE Quantitative Reasoning section that could apply to the same question. So there's not always one way to solve the question. The test maker will, however, try and tempt you into going down the longer path. And if you weren't familiar and really confident with how the different formulas work and the rules and the patterns, etc., behave, you may even not have a choice but to go down the quote unquote long path. And like I said, you need to get good at doing this stuff quickly. So yes, there is a formula that exists where you would rely on the common difference. I won't go into that too much here. I'm going to use a different formula because it's going to be a lot faster, but I just thought it was worth mentioning. So just to add to this understanding of the sequence, we know because they're consecutive integers, we know it's an arithmetic sequence, we know the common difference is +1, we know that it follows the form n plus 1, n plus 2, n plus 3, where n is the first term and n plus 4 is the n plus 3, sorry, is the fourth term. In this case, it equals the last term, okay, of this particular sequence. Now, the question wants us to find the sum of the arithmetic sequence, but as long as it satisfies this restriction, and we want to actually know what the smallest sum is going to be. So find the sum or sums. In fact, the long way would be find all of the sums of this sequence that satisfy that equation and then choose the smallest one or the least possible value of that sum, the smallest sum. Gosh, that is going to take us a long time. There's definitely a faster way. Right, let's go into this. So we're going to use the formula for the sum of the terms in an arithmetic sequence. That is sum equals middle term times by the number of terms. Okay. The middle term in a sequence with an even number of terms, okay, the middle term is always the median. In an odd number of terms, that's pretty easy. In an even number of terms, you can actually take any two terms that are equidistant from the center uh, and divide them by 2. Essentially, you're taking the mean of, or the average of two terms and dividing it by 2 to find the median. So it's kind of a, well, this would be something that you would know about your mean median modes. You would know this rule for finding the median term. And so we have in an arithmetic sequence that could be the two middle terms. That would probably be the formula that you're familiar with, but actually in an arithmetic sequence, it could be any two terms that are equidistant from the middle. And I guess that's actually true, generally speaking. So here you would have the middle term, and we're going to pick on the first term plus the last term. Okay, so that's the first term, that's the last term. We're going to divide the whole thing by 2. That's going to give us the middle term. So now let's just kind of plug our values into the formula and get going. So we have the sum equals the middle term, that is n plus 3, okay, over 2. That's just the middle term, times by the number of terms, and in that case, that's 4 terms. There are 1, 2, 3, 4 terms in the sequence. Right. What we're going to do now is rewrite this. The sum equals, okay, 2n plus 3 times by 2, because we've actually just cancelled that out to make the 2's, right? So we've gone 2n plus 3 times 2. Another way to say that would be 2n plus 3. Another way to say that is 4n plus 6. Now, again, if you're familiar with number properties, rules, patterns, methods, etc., you would know, you would spot this as an opportunity to factorize. And you actually want to split this out a little bit. The more you practice, the more you get confident, the more you build that kind of intuitive sense as well as to what you're wanting to do, especially when you're under extreme time pressure. You're going to want to be able to rely a little bit on that gut feel. Here we have, here we're going to split this out, and we're going to say that actually equals 4n, right, plus 4 plus 2. Okay, so I squeezed it in the bottom there. What does that give us? The sum actually gives us n plus 1, 4n, sorry, plus 1 plus 2, right? That is what we got from this. Okay, now we are in a position we can do a little bit of reasoning. And again, you want to rely on your knowledge to minimize the number of calculations that you do. So you actually want to minimize the number of calculations or minimize the arithmetic and just the heavy lifting that you need to do to solve these questions, and just use reasoning as far as you can. We know that the sum is going to be a multiple of 4 plus 2. Because if you actually rewrote that, I'm going to write this in blue so we don't get confused, but if you rewrote that, that's basically saying 4x plus 2, right? That's basically the sum. So that means a multiple of 4, okay, plus 2 is the sum. What can we do immediately? We can immediately get rid of 8 and we can get rid of 12, because those are actually just multiples of 4. So those won't fit this formula, so we can already eliminate those. Now, just want to touch base on our next strategy, back solving. We're going to back solve because we want to find the least possible value. That's usually kind of a clue as to the method we're going to choose at some point throughout this solution. And we're going to go for back solving at this point. Why? Because the test makers know that you might want to use back solving. Like I said, it's a clue. And once you've gotten rid of kind of two answer choices, generally speaking, you'll be fine to get the third or the fourth. They're not going to punish you too hard by back solving without kind of knowing, or without being able to lean on your understanding of the numbers and the properties and relationships and so forth. But of course, if you're able to eliminate those questions faster with a different method, then back solving would be a great way to take you the final straight. What we're going to do is back solve. So we're going to say that the sum is -6, and we're going to kind of plug in the terms and try to set up this equation so that it meets this criteria, the AB equals C to the power D. Right, so I'm going to back solve up here. So we have some space. We're going to say minus 6, and obviously minus 6 because B is the least possible value. Minus 6, and what have we said? Minus 6 equals 4n plus 1, okay, plus 2. 4n plus 1. Let's actually rewrite that. And then we're going to take the 2 out. Let's just quickly do that first. So we have minus 8. We're going to rewrite this, 4n plus 1, and get rid of the parentheses because that might confuse you. Now you actually see we can take the 4 out of the, or we can do one better actually. We can say that is actually 4n plus 1 because 4 times 1 is just 1, or 4n times 1 is just the 1. So we can take that out and we can divide this by 4, divide this by 4. So we have minus 2 equals n plus 1. Then we have minus 3, because we're going to minus the 1, minus 1 equals n. So we know n, the nth term, equals minus 3. Now, generally speaking with arithmetic sequences, the sum of the terms is going to be the least when we minimize the first term, or minimize all of the terms. And you do that by minimizing the first term. So we have minus 3 as the nth term. Okay, that's the first term. We're going to now write our arithmetic sequence because we know what it is. Minus 3, minus 2, minus 1, 0. That is our sequence. Okay. Another point to remember is that these are not in the same order. They don't have to be in the same order. So you might now think, if you were going to fall down the trap, oh, a to the b, so minus 3 to the minus 2 equals minus 1 to the 0. It doesn't work. We must now eliminate b because that didn't satisfy the equation. Let's now go to c, minus 2. But that would be a RTFQ problem. RTFQ. This is a clue again, RTFQ. We can choose any of our terms in the sequence to satisfy that equation. Now I'm going to lean on 2 exponent rules here that you want to know that will help you get there super quickly. The first one, or actually I'm going to tell you 3. The first one is 0 because we have a 0, so that should be a clue as to the rules we want to lean on. 0 raised to the power x is always going to be 1. Okay. We have a negative 1 and we have also all these other negative numbers. So that's a clue to the other rules that we're going to lean on. Let's say negative 1, okay, raised to a negative even integer is always going to be 1. And then we have another one, negative 1, raised to an even odd integer is always going to be negative 1. So if we can get this equal to this, right? We've satisfied that equation. Let's see if it's possible. 0 to any number minus 2. Or actually, let's not do that. Let's say, sorry, you guys, I've made a mistake. 0 to the x is 0. The rule is a negative any number x to the 0 is going to be 1. Sorry, you guys, I'm so sorry. So let's lean on that. There you go. An extra number property for you guys to walk away with. So x to the 0 is minus 1. So we're going to say, let's go with minus 3. Yep. And let's go with 0, obviously up here, equals 1. Now we're going to do another minus 1 because that is a restriction here. So minus 1, okay. And it's an even number, so that's why we chose minus 2 for this. we're going to say is going to equal 1. Bingo, bingo, that works. We know that B is the answer.